Questions 21 through 25 of the 1999 Grade 7 Gauss Math Contest is what I will explain in this video. A game is played on the board shown. In this game, a player can move 3 places in any direction, up, down, right, or left, and then can move 2 places in a direction perpendicular to the first move. If a player starts at S, which position on the board, P, Q, R, T, or W, cannot be reached through any sequence of moves? Okay, so let's use their rules and see what we get. So we're going to start at S, and we can move 3 places in any direction. So let's go 1, 2, 3 up to here. And then we can move 2 places in a direction perpendicular to the first move. So 2 places would bring you at P. So P is something that we can definitely reach. So now let's go in another direction. 3, 1, 2, 3, and then we can move 2 places in a direction perpendicular to the first move. So 1, 2. So R is something we can reach. So P and R are so far our letters that we know we can reach. Can we reach any more? Well, they're saying that only one cannot be reached, so we've got 2 more that we have to find a path to. Let's go back to the first path. 3 up, 2 across, then 3 down, and then 2 across will bring you at W. So now we got P, R, W as the ones that we can reach. P, R, W. Now we're down to Q and T. Let's see, how can we get to either of these? S, go up 3, then we move 2 perpendicular to the first move. Let's go down 3, and let's move 2 to get to W. Now at this point, use a different color. Let's move 3 to the left, because that's allowed. And finally, move back up 2 to get to Q. Now with this question, I looked at this question a long time, and I wondered if this is even worded properly, because the key here is that they're saying, then can move 2 places in a direction perpendicular to the first move. Now notice in what we just drew, the first move was here to here. But then my last move is here to here, which is parallel to the first move. But then I thought about it and I said, well, it's a grade 7 exam. I don't think they're really looking at it in that much detail. I think when they say, then can move 2 places in a direction perpendicular to the first move, I think they are just referring to the second move. So my second move was right here. And then you just follow the 3 places in any direction, and then 2 places in a direction perpendicular to the previous move. You see what I'm saying? So honestly, unless anybody who's watching this can tell me what I'm missing in this question, I really racked my brain on this, and I couldn't come up with a logical explanation as to why Q is indeed reachable. But in any case, the ones that I cannot reach for sure is T. So the answer to this question is D. 42 cubes with 1 centimeter edges are glued together to form a solid rectangular block. If the perimeter of the base of the block is 18 centimeters, then the height in centimeters is. All right, so they've got 42 of these cubes, right? These little guys, and they're making a block. So we have no idea what the dimensions are. So I'm just going to make a little cube block like that, just for illustration purposes. We have no idea what the lengths are. Okay, so this is sort of our block. That's what it's going to look like, and so on. Now let this part here represent the base. I'll shade it in red. And we'll label it X and Y. And then this part here, we will call the height. So we'll call it H. H for height. Sure, why not? So they have told you a little bit of information that the cubes have 1 centimeter edges. Okay, that helps. And the perimeter of the base is 18. So this was the base, remember. So the perimeter is 18, so that means that x plus y is 18. And therefore 2x plus 2y is 18. And therefore x plus y is equal to 9. All right. So that's about all we get from that piece of information. Now, where do we go from here? Well, we know that there's 42 cubes. Each cube has an edge of 1. So the volume of one cube is 1 times 1 times 1, which is equal to 1. So the volume of this whole block would be 42 times 1, right? Because it's just 42 cubes put together. So the volume of the entire block is 42. So if we put that into an equation with our letters, we get x times y times h is equal to 42, like that. Length times width times height. And then what we can do is we can use this here and substitute that. So we'll call y 9 minus x, and we'll put that into here. So it would give us x 9 minus x, h is 42. And therefore height, which is what they want us to figure out, is 42 over x times 9 minus x. Now at this point, what do? Is there some formula, some quadratic equation? And the answer is no. At this point, we have to use something known as inspection. And this is done a lot in math contests where you get to a point and there's nowhere to go. So you have to just look at it and see. Because these are going to be integers, we can use trial and error. Well, if x is 1, what do we get? Let's put this up here. If x is 1, we'll have 42 over 1 times 8. So 42 over 8. And that's not an integer. Because remember, the height has to be an integer, right? It's just a bunch of series of blocks. So x can't be 1. Let's try x equals 2. If x equals 2, we have 42, 2 times 7. And this looks like 42 over 14. And that means h is 3. Great. There you go. You got the answer without too much trial and error. So the height is 3. And the answer, therefore, for 22 is D. JKLM is a square. Points P and Q are outside the square, such that triangles JMP and MLQ are both equilateral. Okay? And therefore the size and degrees of angle PQM. So they're asking for PQM, this angle right in there. Okay, gonna draw this a little bit bigger. All right, so we've got this a little bit bigger now. So let's start filling in all the information that they told us. They told us, first of all, that JMP and MLQ are equilateral. So JMP are equilateral, so that means all these sides are the same. And similarly, ML and Q is also an equilateral triangle. Okay? And any other information? I think that's it. Okay. So we know one thing, that this is a right angle because that's a square. And we also know that because these are equilateral triangles, each of their angles is going to be 60. So that's 60, that's 60, that's 60. And then this angle in here we don't know, so we'll call that x. And this is also an equilateral triangle, PMQ, right? It's equilateral because these two sides are the same. So that means this angle and this angle are the same. So I'll call it y and y. All right? So the first thing I think we need to do is figure out x. So all the angles going all the way around is 360, the sum. So that means that 360 is equal to 90 for this right angle, plus 60 plus x. And therefore, x is going to be equal to 150. All right? Now if you look at this triangle PMQ, that one there, the sum of those angles will be equal to 180. So we've got x plus 2y. X we know is 150, and therefore 2y plus 150 is equal to 180, and 2y is 30, therefore y is equal to 15. And that is the angle that they're looking for, PQM. So the answer to this, number 23, is B. Five holes of increasing size are cut along the edge of one face of a box as shown. The number of points scored when a marble is rolled through that hole is the number above the hole, which are these numbers right here. There are three sizes of marbles: small, medium, and large. The small marble fits through any of the holes. The medium marble only fits through holes 3, 4, and 5, and the large fit only through hole 5. You may choose up to 10 marbles of each size to roll, and every rolled marble goes through a hole. For a score of 23, what is the maximum number of marbles that could have been rolled? Okay, small marbles, we can have as many as 10. Medium marbles, they're saying you can choose up to 10 marbles of each size. And same thing with large. And we want the maximum number of marbles for a score of 23. So let's start with the small ones. And let's say we have a full 10 of them. And let's make them go through the smallest, because that gives you the smallest score, because we want to maximize the number of marbles. So let's say they each go through hole 1. Okay? So 10 marbles, each of them going through 1. So the total number of points or score here would be 10. All right? Now we've exhausted the small marbles because we can only choose a maximum of 10. So now let's turn our attention to medium marbles. And let's see, we've got 10. We had a score of 23 as our goal. So we've got 13 more points that we can obtain. So the medium can only go through 3, 4, and 5 according to the question right here. So let's make them go through 3, hole 3. And let's choose, that would be 4, right? But if you have 4 and they all go through 3, that's going to give you a score of 12. But 10 plus 12 is not going to be 23. So that's no good. So let's use 3 marbles that are medium that go through 3, hole number 3. And that would give you 9 points. So 10 plus 9 is 19. So we still have 4 points more. But we can achieve that with 1 medium marble going through the hole with the 4. That would give you 4 points. So our total number of points is 23, so that matches. And our total number of marbles looks like 10 plus 3 plus 1, which is 14. So the answer to number 24 is C. Number 25, in a softball league, after each team plays every other team 4 times, the total accumulated points are Lions 22, Tigers 19, Mounties 14, and Royals 12. If each team receives 3 points for a win, 1 point for a tie, and no points for a loss, how many games ended in a tie? All right, let's make a little list here. We got Lions, and the Lions play the Tigers 4 times. The Lions will play the Mounties 4 times, and the Lions will play the Royals 4 times, like that. And then the Tigers will play the Mounties 4 times, and the Royals 4 times. And finally, the Mounties will play the Royals 4 times. And then all the others are just repeats of each other. So the total here, 4, 4, 4, 4, 4, 4, is 24 games in total. Now let's start with extreme case scenarios, which is, let's say every game ended in a win. 24 games, all of them ended in a win. So that would mean that every time there's a win, it's 3 points. So 24 times 3 points each would give you a total of 72 points. And that's a scenario where all the games ended in a win. So one team won, got 3 points. The other team lost and got 0 points, and there was no ties. Now, what is our point total? We have 22, 19, Mounties had 14, and the Royals have 12. So our point total looks like 67. Oh, okay. So we definitely had some ties. So let's work with that. If there is 24 games and 23 have wins and 1 tie, our point total will be as follows. You'd have 23 times 3 plus the 1 tie gives 1 point to each team. So 1 point for the first team plus 1 point to the second team. So our grand total of points would be 69 plus 2, which is 71. All right? Now we have 67. So we have to somehow figure out how many ties would allow us to get a score of 67, a cumulative score of 67. So this was 1 tie. Now let's try 2 ties. 2 of the games ended in a tie. So that means that the 24 games, 22 were wins. And then we had 1 plus 1, 1 plus 1, right? The 2 games that are ended in a tie, each team would get 1 point. So this looks like 66 plus 4, which is 70. All right, we're moving down here, so eventually we should be able to get to 67. 3 ties, same story, 21 times 3 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, all the ties. So this looks like 63 plus 6, which is 69. All right, keep going. We're pretty close here. 4 ties, 20 times 3 plus 1 plus 1, 1 plus 1, 1 plus 1, and finally the 4th tie, 1 plus 1, and this gives you 60 plus 8, 68, and I think we are now at our number, so this would be 19 times 3 plus 1 plus 1, 1 plus 1, the 3rd tie, the 4th tie, and the 5th tie, and this gives you 57 plus 10, which is 67. So in order to get a cumulative score of 67, you need to have 5 ties. And therefore, the answer would be C.